Hey everyone, welcome back. This is Professor Xiao. The purpose of this video is to help you with a specific homework question. The question is hands-on practice, so let's go to a Jupyter notebook. All the demos in this video is based on the dataset YULP1. This video may use some of these packages, especially RE for regular expression, GenSim, and scikit-learn. Note that I use the NumPy random seed 1 and random state 1. After reading the dataset, here is a high-level information about the dataset and the columns included. I printed the first 10 rows of the data by selecting a few columns. We will be focusing on the review text column of this dataset, which includes each of the review texts. The first review text, the second review text, and such and such. Each review text is referred to as a document. This is how NLP programmers refer to the texts, and the entire column of review text will be called a corpus. Now let's look at a specific problem. The demo in this video assumes that you have followed 2 other videos on how to clean and prepare or pre-process the YULP review text corpus. So for the demo, I will use the review text column in the data frame df2. This video is a quick demo of how to extract the top terms or top words of each of the topics after you have trained and fit an LDA model to the YULP review data. I assume that you have followed through several of my other video tutorials on how to clean and prepare YULP text data, how to train and fit a bag of words model to the data, and most particularly, how to train and fit an LDA model to the bag of words data, the term frequency table. After doing all of those preparations, you are now ready to extract the top words or terms from each topic. In the previous training, I specified the number of topics as 5, so here I will get the top 10 words of each of the 5 topics. Keep in mind that if you have specified a large number of topics when you train the LDA model, this list here, the output can be really long. To be able to complete this demo, you will need and understand 2 data objects and a technique. The 2 data objects are the feature names list and the topic word distribution table. The feature names list is a list of terms whose index positions correspond to the index values of those terms in the vocabulary of bag of word model. The topic word distribution matrix provides a measure of how important each word is given a specific topic. The special technique is the list comprehension. To be able to finish this task and write codes that are elegant and short as well as readable, you will need to implement the list comprehension approach. So let me go through the code line by line. I create a variable which specifies the number of top words that I will extract for each topic. Here I will extract 10 words from each topic. Then I construct a for loop. In doing this for loop, I use the enumerate rather than using a range iterator because I can directly get the content of this topic word distribution matrix. In that case, I do not have to slice that specific row whose content I will be using. This enumerate function will take this matrix row by row and in each iteration return the index of that row as well as the content of that row. So the index will start from 0 and onward. The content of that row will actually be a one-dimensional array. Inside the loop, the first thing I'm going to do is to print some information. I will print an empty line just to make sure that this iteration's printout leaves a gap from the previous printout. Then this indicates the index value of that topic that I'm printing, and I'm using a dot format string method to print this index value conditional on the specific loop. Next, what's remaining is just a line of code. It's separated by 2 lines because it's getting too long, but still it's just 1 line of code. In this line, I'm first putting together all the top words into a long string separated by a comma and a space, and then I print it out. I'm using the strings .join function so that I can join together a list of strings separated or delimited by the delimiter. This is the delimiter. So imagine that you have 10 words. The 10 words are glued together into a long string, but between each of the word, I have a comma and a space delimiting each of the words so that I can see them clearly in one line. Now the focus is the list comprehension. This is perhaps the most complex part of this task. To use a list comprehension, you will develop your codes inside a list notation from this part to this part. For now, ignore this part. It's a special slicing notation. In this list comprehension, it's just like a for loop concisely written in one line. For each I in the topic row.argument sort. What does that mean? Topic row is the one-dimensional array returned by each iteration of the for loop. So for a particular iteration, this topic row will get the term importance of each of the terms with the index corresponding to the term index. I would like to sort the content of this array so that I can get the X number of terms with the largest numbers in this array. So I use the Arg Sort. What does this do? It sorts the content of this one-dimensional array based on the values of the array, but instead of getting the values in the end, it will get the original index values of those values after being sorted. I hope that makes sense. So the result of this part will be the index values of those content of the one-dimensional array when the content is properly sorted in an ascending order from small to largest. So you can imagine that the top elements of the result of this code is the index value of the original one-dimensional array that has the smallest value of the element. Conversely, the last element of the result returned by this code is the index value of the value element that has the largest number in the original array. So by the end, what I get is the index values of the value of the matrix after being sorted for the particular row. So now I would like to get those index values for the largest numbers. Because it's sorted by ascending order, the largest values are in the tail. So I want to extract the tail, the X number of index values in the tail. So I use the minus sign to get the last few elements. Slicing from that index minus something is counting backward. The minus 10, here the value is 10. From minus 10, slicing to the end, omitted here meaning slicing to the end. This will slice the last 10 elements of the returned array. So this part of the code, by that I get the 10 index values of the content of the original array that has the largest numbers. To make some correction, this whole part actually is inside the list comprehension, not until here, but all the way until after this portion. So let me talk about this. This is a special notation to slice the list backward. From beginning to the end, both beginning and end are omitted, assuming that this is taking the entire list, but with the step as -1, which means after slicing, it will get the contents of a list from the end to the beginning. So this is another way to say sort this backward. That's it. This notation essentially sorts every element backward. So what do I get by the end of this part of code? I get the index values of those values of the array that are the largest, meaning the index values of the terms that have the highest importance for this particular topic. And since the original 10 items are sorted in ascending order from least important to most important, I like to reverse the order by arranging the index value for the term that has the highest value of importance. So this result is a list. Now let me talk about the list comprehension. For I in this list, what do? I use the index value to extract the term. Recall that I said in another video that you can use the feature names to extract the term by using the index value, the unique identifier of each term. So for every element of that selected index values, I will get the term and I do something. Recall that each term, after using the preparation that I explained in another video, you have the POS tag at the end of each term. The POS tags are not very helpful in terms of interpreting the term's meanings. So in doing this task, I will strip the POS tags. So I use a split function of the string to split by the slash. So by the end, I will get a 2-item list. I will only extract the first element of that 2-item list, which is the term itself. So I get rid of the POS tag as well as the slash. I only retain the term. So by the end, the list comprehension all the way to this point will give you a list of simply the terms for each topic. These terms are 10 of all the terms with the highest importance values. So let me run this. There you go. For the 5 topics that I have for Yelp restaurant review text data, these are the top 10 terms for the 5 topics. By reading these words, supposed to be the most important and relevant terms to each topic, here is what I have come up with as a brief description of each of the topics by using the clues provided by these terms. Here is what I have come up with as a brief description of the topics. I think they make sense. The first one is about customer service because most of these top terms refer to the actions that you do interacting with the restaurant, the wait time, waiting for a table, and the persons in that environment. So it's most related to the customer service. Topic 1 is most likely about Japanese cuisine. It refers to sushis and rolls as the top words. Topic 2 is most likely a traditional American cuisine, including burgers, pizza, sandwiches, and fries, as well as cheese. People seem to love it. Topic 3 is most likely about Mexican cuisine because the top words include taco, salsa, chicken, steak, as well as something related to the customer service. And the last topic is most likely about Chinese cuisine because it mentions spicy, rice, and some of the other meat choices and flavors. This obviously isn't really 100% scientific. This is interpretation based on the top words after training an LDA and fitting it on a fairly large and interesting data set. So this concludes the video demo. I hope you enjoyed this video. See you next time.